In an earlier short video, I talked a little bit about angles and how folds are basically bisectors. I want to explore that a little more here. So I'm going to take, again, this corner. I'm going to fold it in some random angle. Doesn't matter what the angle is. Totally irrelevant. Okay. Again, I'm going to draw this line, although this is not be critical for what I'm talking about here, but higher mathematics. I'm not going to fold this edge to match up with this. So if you look at that carefully, I folded this angle in and I folded this angle in. And I showed earlier, and we can clearly see that this is a right angle down here because we took a 180-degree angle when we bisected both parts of it. So it's always going to be a right angle. But more importantly is these two triangles have to be similar. Notice if this angle over here was A, and this angle is B, A plus B equals 90. But this angle plus this angle must also be 90, so that's got to be B. This angle plus this angle must also be 90, because you have a right angle up here. So this over here must be A. So I just made two similar triangles. Now, if I know the length of the side of the square, I know I can sort of, these two here have to add up to that. So if I know one or two measurements here, I can automatically find all the others by doing similar triangles. Notice, if I fold over here, and match up with that edge, I will again make a similar triangle. So every time I do this fold, I make a similar triangle. Now this time, on the last one over here, I still get a similar triangle even though I've got this gap. Now one of these folds may not create a triangle, it might go over the edge, that's okay. Just think about extending it. But again, it's a quick way to make similar right triangles. Once we know a couple of measurements, we can figure out everything else using some basic trigonometry. But again, it all boils down to that fold being that angle bisector.